Okay, so hello everyone. Welcome to today's session of uh, Introduction to Azure Fundamentals. I hope I am audible to all of you. All right. So to begin with, let's first understand, like before we dive into Azure fundamentals, we all must know what is cloud services and when do you need it? Like, what is cloud service? Does one need to learn it? Does one need to use it? When to use it? And how it can leverage the computing power throughout the distributed data centers to power your applications and to power your to power your backend servers or anything that you want actually to deploy through a cloud. So to begin with, imagine that you have written a piece of code and it's running well on your system. um, Everything is going fine until you are working on your own system. Now you want to expand that code, you want to sell that code and make it available throughout the global content delivery network. You want to make it available globally for everyone to use it, and maybe you can generate some revenue and you satisfy the end user goals. You address some end user problems. Now that is where you should technically preferably use cloud services. Now to think about it, what are the drawbacks when you actually use something locally on your system, right? In that case, you're going to face n number of issues. For example, your website, your service needs to be available 24/7, right? It can be accessed from anywhere. It should be accessible all the time and anywhere. So what is the problem that you will face when it runs on your system? Imagine network loss. Imagine power failure. Imagine something goes wrong with your system. Imagine some crucial data that is available on your system and your system goes down. So how does a local system address those problems? We can find n different solutions to it, but none of them are gonna work until we are on the local system. So here comes cloud. Cloud is basically imagine a data center in a remote place which is managed by someone, which has virtually an unlimited number of, let's say, virtual machines. So you must know what is a virtual machine. Let's say that there is a data farm in which there is server, there is a computer, and you can headlessly use it. So basically you are only paying for the amount of time that you use it, and in that way you have an access to an unlimited amount of compute power. Now you don't have to worry about maintaining these devices, paying for these devices, or actually purchasing these devices or maintaining these devices are purchased, kept and maintained for you, and they are connected to a very reliable source of network. And from there you can just use it through your let's say this Azure portal, the one I am on right now, or you can use it through your command line using the Azure command line tools. Now there are and different benefits that you get by actually shifting to a cloud services portal rather than your local system. On your local system, let's say um, your system fails and you lose the data. That is never going to be a problem in cloud, because the way Azure is built, let's say you put some of your data into an Azure machine, right? And which this machine which you might call cloud is actually located somewhere in a remote place. So in reality, that data is replicated into n number of different virtual machines. This virtual machine on which your system is running, if that goes down, this data will actually be present on n number of replicas which are in different data centers. So let's say an entire Azure data center fails. it's very unlikely, but let's say a catastrophe happens and one of the data center goes down. So does your data go away? No, because your data is available in n different machines in n different data centers. It is distributed throughout. Now there are two different benefits that come up when data is stored in different data centers, when it is replicated across different data centers. One, when if one of the data centers goes down, you won't lose your data. Second, let's say some of the users are in a different zonal area. For example, some of your users are from India and some of your users are from, let's say, Florida, America, right? So if the data for the Indian users is being fetched from the American database, or let's say a server which is placed in a different region, it's going to take longer as compared to other data servers. So the zonal databases, the distributed storage of data, make sure that your users get the data effectively. That is, the data is immediately available and latency is minimized, right? And one another benefit that you get of actually using cloud services, you get an limitless access to databases. So for example, an SQL database, here you don't have to actually worry about your system running out of space, or let's say at the starting point when your business has not grown, you think that 100 gigabytes of data is going to suffice you. So you get 100 gigabytes of storage into your system and you run your services on premise, that is locally on your system. Everything runs fine until one day your system actually your business actually hits the market, and the data storage, you just cut off the data storage, right? Because 100 gigabytes is nothing if we think about real world scenarios. I'll give you an example later. First, let's understand how is 100 gigabytes not going to suffice us. Think about a situation: your system actually, your product actually hits the market, and within a fraction of time, 100 GB seems like nothing, and it will happen very soon. So technically, what you will do to provide to continue providing your services, you are going to get to the shop, buy some storage, you're going to order some, let's say, disks, some SSDs, you upgrade your system and you go live again. But it's going to happen again because real world traffic, 100 gigabytes is nothing for it, 1000 gigabytes is nothing for it. You're going to exceed it in a fraction of time. So sooner or later, you think about cloud. Now how can cloud services solve this problem? Like we discussed before, cloud provides you an access to a virtually unlimited amount of net compute capabilities. So similarly, you can subscribe to storage because the remote system in the data center, the remote virtual machine in the data center, those are all headless machines. They have an virtually infinite amount of storage. In today's world, you don't have to worry about the amount of storage that is available to your cloud system. You basically just need to subscribe it. You basically just need to subscribe it, and you just pay for the amount of storage that you'll be using. You don't need to think about getting the storage, upgrading your system. What happens when your system upgrades? Your server is going to go down, right? You cannot upgrade to a live server. You cannot update the physical components of a live server. You don't need to worry about those things. You just upgrade to a storage, you pay for the amount of storage that you're going to use, and you can use it. And all this data, and obviously all this extra storage, all this infinite amount of storage that you get is also replicated. Your data, you never lose the data, your system never goes down, and you can expand the storage. By storage, I basically means the volume of memory capacity that is available to your system. So you're never going to cap that off, because when you go to a cloud service, you can virtually extend your services based on your needs. When your traffic goes down, you can shift your services down. When your traffic goes up, you can request for more services, and it's going to be available to you. And you only pay for the amount of services you use. In terms of in terms of compute capability, you only use for the amount of time your resources are being crunched. So that's how it works. And to talk about a real world scenario, I hope all of you must have heard about Shopify, right? Can I get a heads up in the chat if you have heard about Shopify? It's a very famous shopping website. So recently, during the a Black Friday sale, which was not very long ago, Shopify had hit a capacity, an ultimatum of around 67 petabytes of data every hour was flowing through the system. 67 petabytes of data is no joke, right? Like 1 gigabyte, when you multiply it by 1024, it becomes 1 terabyte, right? 1024 gigabytes is 1 terabyte, and 1024 terabyte is 1 petabyte. And imagine an e-commerce website which hit its peak on Black Friday sale was around 67.5, 47.5 petabytes of data every hour was flowing through the system. So obviously now you can imagine how real world why real world applications, why real world services cannot be running on your local system and on-premise system, right? And cloud services allow you to address these problems, allow you to expand according to your needs, allow you to compress according to your needs. Basically they are flexible, and you only pay for the services that you use. You don't have to worry about maintaining your system, protecting your data, and all those things. So those were the few reasons why cloud services is better than using your on-premise systems. And now to talk about certain cloud services, there are many. Azure, Microsoft Azure, then there is Google Cloud Platform, and then there is Amazon AWS, Amazon Web Services, right? So today we are going to talk about one of the most flexible and most and a cloud service which comes with the innovations of Microsoft. Like Azure is not a product that is that where you might ever feel bottlenecked. Like it keeps continually upgrading with the latest Microsoft services. So to talk about a few services that Azure provides, let's let's go to my dashboard, right? And here you can see a lot of resources. For example, there is something called function app. So a function app is basically nothing but an asynchronous application which allows you to run some background tasks. So for example, let's say you have a piece of code and you don't exactly know how to build a container out of it, or how to ship it along with its dependencies. You are not sure is it going to run on your system, in the cloud system, because just because it runs on your development system, you cannot say that it's not going to fail in the prod without further testing it. In those cases, this thing, the function, the Azure Cloud Functions is something that can save you. What it does is it's a completely managed system with comes with all the dependencies. You can actually install your dependencies into here and start using it. And this can complete your needs, and as in the needs of your end user product. It can run those tasks asynchronously. You can manage the logs, you can manage the amount of storage and the amount of compute power available to each of those instances. And every time an event happens, an event can be anything. For example, an event can be an HTTP endpoint that your users hit, for example in URL. An event can be any change in your storage. Let's say a new file is added, or a file is deleted, or a file is updated. These kind of bucket events, all those events can trigger a function, and this function will open up, do the specific task, and go back offline. So and you will be charged only for the amount of time it was crunching the resources, it was utilizing the resources. An example of where you can actually use the function app, I'll give you one example from my personal experience. I was building a software which actually stores which is actually a cloud drive, a drive to store all your documents. And it allows you to access your documents based on authentication. So you can log into the product using your, let's say, an email ID and password, and there you can upload an infinite amount of documents. It could be anything: image, video, PDFs, docs, excels, anything. So it was basically a product to store data remotely, a backup, a kind of a backup drive. So there, what I wanted to do was, the moment someone uploads a video, I wanted to show a thumbnail. And thus and through server side coding, I had made most of the things wherein I could generate a preview for most of the things. For example, if someone uploads an image, I can show the image as a thumbnail, not a problem. But what about a video? I didn't want to create some front end side code that actually reads the video, because to read the video you need to get a chunk of the video, and to get a chunk you need to temporarily download the video. What if the video is of 10 gigabytes? So how do you show a thumbnail of a 10 gigabyte video? And to generate a thumbnail which is actually a file of few kilobytes, I'm not going to download a 10 GB video file, right? So how do you generate a thumbnail in those cases? Cloud function can be should be your preferable way to go with it, because using cloud function, what you can actually do is I think if I can show you a demonstration, that would be good. Okay, it would require me to sign up the service. I'll explain you cloud functions along with this example, right? So let's say you go to a function app and you create a function app. So what this will do is every time a new video is added to your bucket or to your storage, like I told, a storage event can trigger a function app. So let's say a new video is added and that triggers a function app. So here I don't have to worry about actually scaling this service or managing this service, and what if the service fails at any point of time. I just have to worry about the event, because rest of the things is being managed by Microsoft Azure, right? Because the function app is a fully managed application, you can say that it's fully managed. So let's say a file was added to the bucket, and the moment a new file is added, it creates an event of new creation. On based of that on basis of that event, the function app triggers, it reads the video locally on the on the backend side. It reads a single frame and uploads a particular frame to the let's say to a drive to another bucket, and that bucket link is made available to you. And all of these links are secured because your entire service is running on Azure, right? So only ingress private IPs are allowed. So that's not going to be a problem. So the moment a new video file is added, a bucket event triggers and a new file is available to you. That is an image or a preview frame that can be used as a thumbnail for your video. So that is something where function app can be used, an example. And it's up to your creativity where you want to use it, because here you don't have to worry about a lot of scaling, or mostly nothing except your business implementation, or the business logic in technical terms. So once you implement your business logic, and you don't want to take care of the scaling, and you don't want to take care of how these events trigger, you don't want to um, like this is a lightweight task, and you don't want to rent out an entire virtual machine instance, you don't want to configure the dependencies onto it, which can sometimes be a nasty job. In those cases, function app is going to save you, because it will manage most of the things for you, and you just need to give it the business logic. Then there is SQL database. So I'm pretty sure we are all well aware about what SQL is. It's a relational database management system, RDBMS. And using SQL queries, you can manipulate the data, walk through the data, read data, add new data, all those things. And SQL data, obviously, it is used for its consistency, and it's most more significantly because of its querying capabilities. You can do a lot of things with SQL. And in those cases, let's say you want to deploy your SQL database onto your cloud system. Let's say you have a backend, or you have something that consumes the data from a RDBMS or an SQL database. So you don't have to worry about actually uh, you know running this database locally, managing the database, or what happens if your system goes down and the data goes down along with it. You don't worry about those things when you use a cloud database, for example an SQL database on Azure. In Azure, when you use an SQL database, you have the flexibility to control the number of replicas it has. So your data is always protected through, and it's present in different um, uh, you can say it's present in different data centers securely, so you can use it on demand, and your systems can directly connect to it through its public IP, or if you're running it within, or if your backend is running within Azure, you can say an internal private IP to increase the security. Or there are different cloud auth proxy gateways through which you can authorize different external networks to access it as well securely. or there is another method to use it, which is called TLS or SSL certification. Those certificates allow you to access the database even more securely. But my point is, you don't have to manage these databases on your system. You don't have to worry about data loss. Basically, you allocate a database, you run it on the cloud, and Azure will make sure that your data is managed, your databases are managed, your data is replicated and always globally available. And if you opt for a zonal distribution, then obviously your data is going to be even more accessible because of the less latency, since it's zonally distributed. Right. I hope you guys have no questions still here. If you have, please feel free to ask me in the comments. Then Cosmos DB is something similar, but on top of that, it's going to be NoSQL. So both of these are databases which are managed, highly available database networks. One thing is SQL based, and one thing is going to be NoSQL based. It depends upon your needs. Or you obviously, this is for systems when you want to complete access on top of your data. Let's say you don't want to worry a lot about the database management, then you can obviously opt for other managed databases like MongoDB or any cloud deployment center. But for SQL, I would highly recommend that you use data on your system, because here you have all the flexibility, all the control over your databases, and you can manipulate, model it the way you want. Then comes something that is, I think, 99% of cloud users use. That's going to be a virtual machine, because without a virtual machine, your product cannot be globally available. So what is a virtual machine? A virtual machine is nothing but a computer, or a CPU, a computing power that is running in a remote data center, and that is available to you headlessly. And through this virtual machine, you have an access to a virtually limitless amount of compute power. So a virtual machine is basically something that comes out of virtualization. What you have access to here is, let's say you create a virtual machine, then you decide what kind of operating system runs on it, and you have the assurance that this is not going to fail. And even if the virtual machine fails, your product will not go down, because obviously the virtual machine is replicated, right? If one goes down, other is instantly available to you on a different data center. So data center or availability is not a problem when you use virtual machine. In virtual machine, what you have access to is uh, basically an entire system depending upon your need. Let's say you have let's say your current architecture, that the current system requirements for your product is not very high, so you go for a minimal virtual machine. Let's say 8 gigabytes of RAM, some gigabytes, let's say 25 gigabytes of storage, and let's say 4 gigabytes of sorry, a 4 core CPU, my bad. Based on this virtual machine, based on the configuration that you give, you don't have to buy the product, you just have to lease the amount of time that your service is going to use. So you create a virtual machine with a particular configuration, you use it locally, you use it virtually through your, let's say, Azure portal, because in Azure portal I can just open a cloud shell just like that, and connect to my system and do some task on it. And once you're sure that your product is working, you can shift or make it public, assign it a static IP, and your product is now available globally. And let's say the other let's say in a week, or let's say if you're lucky, in within 2 to 3 days, your product is being used by a lot of people. That is to say that your product is now getting a lot of traffic. In those cases, you don't have to worry about actually upgrading your system, physically assigning new components to your system. All you have to do is upgrade your virtual machine, and and not even your product will go down while upgrading, because Azure comes with the promise of zero downtime, right? So while one of the virtual machines is on and you still know that it is functioning, you create a new virtual machine, or you expand, you give more accessibility, you subscribe to more services on your current virtual machine, and that's it. That's all you have to do. It can now scale according to your need. Or on top of that, you can obviously, if you have studied about architecture, or you have studied about the scaling part of your backend, or let's say your solution architecture has built an architecture for you. So in that case, what most people do is they use a load balancer on top of the virtual machine. So based on um, any kind of load, that could be compute load balancing or network load balancing, your service is going to be dynamically, allocated to different virtual machines, and these virtual machines can obviously instantly replicate them to be more available, so that you never get that error, server is down, server is busy, and those kinds of things. Virtual machines allow you to do that. They are completely managed. uh, the physical entity of the server is completely managed by Microsoft Azure Data Center. All you have to do is configure it, run it, and scale it. Even the scaling is managed, you just need to configure how it is scaled. So that's what a virtual machine allows you to do. You, you can basically run your own operating system, the one that you prefer to, the one on which your product works fine. You allocate it an operating system and you get it live and you assign an IP address to it. That's all you have to do, and then your product is now globally available. Then, as we discussed already during virtual machine, here comes a load balancers. Right. So a load balancer is uh, just like what we discussed in virtual machine. Let's say you have a virtual machine and your product runs on it. Now the traffic increases and you start getting 10 times of what you were getting yesterday. And obviously one single virtual machine cannot handle that load because it has a limited computing power, it has a limited amount of storage. uh, it cannot do that. It just does not have the capacity to handle those many requests at simultaneously. So here comes a load balancer. A load balancer sits on top of a virtual machine, and what it does is it assesses the load on the different virtual machines. For example, um, let's say that you have um, a virtual machine, you have allocated a virtual machine, you have configured it, and you have and your piece of code is running fine on it. Now you know that the capacity that the virtual machine has, it can handle up to 10 simultaneous users, right? So the load balancer makes sure that not more than 10 are routed into that virtual machine. Let's say the 11th user comes and wants to use your product, that will be dynamically shifted or routed towards the new virtual machine, which is basically not doing anything right now. And your services and your virtual machines dynamically turn up. Let's say there is one virtual machine right now and it's 80% there, close to its threshold. Beyond that it won't work. So your load balancer will notice that one virtual machine is being used at its 80% capacity. Two or three more instances are going to be required in case the network increases right now. In those cases, you get that is where the load balancer is going to uh, you know yeah so in those cases the load balancer is going to save you, because now you don't have to worry about your server going down or your server going to a restart, because when the load on the CPU increases completely, the natural behavior of a server is to do a restart, right? A classical example of bad state management. Anyways, uh, yeah, your server is going to restart because that's how the servers are built. For example, if you know something about a mischievous piece of code called the fork bomb, that's how it works. I hope in operating system you have learned about something called a fork. You have a program, and if you duplicate the program, it is called a fork. Because every program has a program ID, you just duplicate the program and run it again. For example, running two different Google Chromes simultaneously, it's called forking. So there is a program called fork bomb. If you run it on on a system, it creates a dummy program and it forks it infinitely. And at some point, obviously your server is going to reach its compute capability and it's going to do a restart. So that's how a server goes down with an attack of a fork bomb. And that is what load balancer will not let happen. I mean, not the fog bomb, but a server going to be going to restart because of n number of users using it simultaneously. So that's what a load balancer does. It sits in front of the virtual machine. It assesses the current load on the virtual machine, and it assesses the incoming amount of requests. And let's say your current virtual machine is about to reach its maximum capabilities, it will instantly allocate a new virtual machine and route the new users or new requests into the new machine. So that now let's say there are 15 users using a product simultaneously. A single virtual machine does not have to solve or address the 15 use cases. It will handle 7, and the other virtual machine can handle up to 8. So it will distribute the request, incoming requests, based on the load or based on the networking capabilities. There are different kind of load balancers. It could be a network based load balancer, it could be a compute based load balancer, and sometimes right now load balancing can even be done on GPUs or virtual GPUs for AI and machine learning data centers. And load balancer is the fundamental piece of scaling. Without load balancers, that there is not going to be any kind of scaling, right? I think it's pretty apparent why that cannot be, because this is what scales the new system. This is what assesses the current load and allocates a new system to you. And talking about load balancers, there is another important cybersecurity topic, or we can say a topic that actually a kind of attack that can take down your server. It's called DDoS, right? Or sometimes called DOS. So a DOS stands for a denial of service, wherein let's say there is a server that is handling some requests and that is making your product available to the internet, to your end clients. So let's say there is a hacker, or what yeah is there any kind of load balancer? Yeah, just like we talked about, there are different types of load balancer. There is HTTP load balancer, which is basically a network based load balancer. There is compute based load balancer, and there is load based, load as in the amount of load that is being currently used on the system, kind of load balances. So there are different kind of load balances, completely depends on your need, what you want to. Let's say you have a compute heavy task, probably you're going to go to the CPU based or the compute based load balancer. Let's say you have something that can create a network bottleneck, that can bottleneck the networking capabilities of your system. If lot of instances run simultaneously, then you would want to use a network based load balancer. So based on your need, you choose the load balancers and you scale your system. Now, a load balancer, and also because of that property, a load balancer is the key fundamental, a key fundamental piece of an auto scaling system, and that is auto scaling groups work through the load balances. And yeah, as we were talking about DOS, DOS stands for denial of service, and sometimes also called DDoS, distributed denial of service. So what a denial of service attack basically means is, let's say you have a server, and every time your server does some task, it is utilizing the resources available on the cloud premise, right, available on the virtual machine. And every time a virtual machine does something, it utilizes the resources. And every time a resource is utilized, you are billed for it. You are billed for the amount of time the service is being used. And that is exactly what a DOS targets. Let's say someone sends a request to do an XYZ task to the server. The server will do it because that's what it built for, right? That is, it's there to provide your service to the people. So your product does its task, it utilizes the resources that is available, and does the task normally. Everything is going fine. And then that same request comes from the same person again. And let's say that person is a hacker. He or she writes a script to add infinite to send infinite number of requests to your system. And all this infinite number of requests come to you, you do the task and return infinite number of results. So let's say this infinite here is, in our context, is 1 million. So you do the same task 1 million number of times because of an automated request that was written by a hacker. So the amount of money or the amount of time that you are using this system for, or the virtual machine, is, let's say, n minutes, n seconds for a single request. Now that is n million seconds, because you were getting a million requests and you processed literally every request. And now you pay for n million seconds rather than the n seconds, because technically only once was enough, because other were clones of that request. And obviously, since it was written from a script and being coming from a same system, it was called it was basically called a clone of the request. So this is how the hacker is hurting your server, or it is basically scaling up your server, because for to process those million requests, your load balancer notice that there are now million requests coming, I need to create n number of virtual machine instances. So your everything worked fine. All your auto scaling advanced concepts that you put into building it, everything worked fine. Your system scaled up, did its job, and is now available to process the next job. But what is the loss that you have to bear because of this? A hacker simply used your product a million number of times. What's the big deal? The big deal is that you have it used n million seconds of resources, and now you have to pay for it. Now, to block those kinds of attacks, there is something called DOS, denial of service. So you set up rate limit, you set up amount of throttling time that is available to the same IP address which is sending you multiple requests. Now, if within a particular time frame you get more than n number of requests, you are going to deny the service, you're going to reject this service and send an HTTP error code. I think it will be a good homework for you if you can go Google out what is the error code for DOS. And then there is an advanced concept called distributed denial of service, where the service requests are coming from different IPs, and then there are algorithms to detect that and deny the service. Now, those things are pretty advanced. But at the same time, a very simple fundamental thing that can help you from your system being abused, DOS. So it's a good practice if DOS is enabled on your backends. And Azure also provides you certain DOS and DDoS protection. I think if I just open up, there are DDoS protection plans, right? Just give me a moment. If I can open up the portal, I can show you a detail how to set up a DDoS protection. But yeah, before we go into details into a lot of things, I think I can show you few more systems based on it, right? Alrighty, let's do that later. Once let's give it the time to set up, and meanwhile we can uh, talk about the different other services available. There are storage account, there are virtual networks. A virtual network is nothing but your own private IP, wherein your system runs, and it gives you an extra layer of security so that your database, for example, you have a database and you have a virtual machine which is utilizing that database, right, which is consuming data from the database or putting data in the database. So in those cases, a virtual network is something that can give you an extra layer of security, because now you don't have to make your database public, or you don't have to assign it a public local IP so that anyone can utilize it. Or even if the public IP has some certain kind of authentications, but there is always an a loophole, right, that your database can be hacked. So in those cases, a virtual network, they provide you faster and reliable connection, they provide you a secured connection, because now all your services, your backend and your database are connected to the VPC, or the virtual private network. And within that, you only authorize your database to accept incoming connections if they are from an internal IP. If it's not, just deny it. This gives you an extra layer of security. So virtual network comes into that. Now, Azure Active Directory is something that comes from an Azure only product. What it does is basically it's an identity management system. Now, there is something that I can tell you about identity management system. It's an extra layer of security. What is extra layer of security? You might ask. Let's say, for example, you are the person who is administrating the project. Now you assign different roles to different people, because you don't want someone, let's say a new intern joins your organization, you don't want the person to have to have a complete access to literally all your products, because if something goes wrong, some product might some product might go down, and there goes your revenue. So an Azure Active Directory, you might have heard about this on different systems. For example, Google Cloud Platform calls it IAM roles, Cloud IAM. Now that is anonymous to this Azure Active Directory. It allows you to authenticate people, give them certain roles, assign them roles, take away the roles later if you don't want to, give them a limited access to your system. Basically, that's it. And authenticate it. There are two. Please don't confuse it with identification. Identification is knowing who the person is, and authenticating is assigning certain roles or certain access to the person. So that is what Azure Active Directory allows you to do. Looks like it's doing a very simple job, but technically it's reliable. You can rely on it, you can use it to assign roles, to provide access, to take back access, and things like that. Then there is Monitor. Monitor is basically a dashboard that you can use to look about the performance, right? For example, I think, yeah, you can monitor a lot of things through Azure Monitor. If I can zoom into it for you, I can better explain that. Give me a moment. Meanwhile, let me check if there is any question based on it. Alrighty. Okay, cool. So, an Azure Monitor allows you to do these six basic things on your on your cloud-based resources. On By a cloud resource, I mean anything that is running on your Azure cloud. It could be a virtual machine, it could be your application server, it could be a container, it could be your Kubernetes engine, anything, right? So it helps you get insights, all the insights in one single place. So let's say you have a server running within a container which is running on a Kubernetes engine, and all of these, if you notice, all of these services are cascaded inside each other. By cascaded, I mean the server is running inside container, which in terms is running inside a GKE or a Kubernetes engine, and that Kubernetes engine is running on a virtual machine. So how do you access the logs of your server, which is cascaded so deep inside the layers? That is where a monitor can help you. You configure the monitor to look for certain files, to access the logs which are literally present anywhere within your Azure cloud. And these things will be monitored and alerted based on certain thresholds that you set up. So let's say you have your server running, and you have set up to maximum n number of replicas allowed, and let's say you are about to hit that limit. You're not going to be sitting on a system 24/7, right, going through the logs and watching the amount of resources, network resources being computed or being utilized in real time. No, nobody can do that. Nobody is going to be sitting on a system for 24/7. So that is where an Azure Monitor can help you. You set up an Azure Monitor to be watching for changes, to be looking through logs, and the moment something is about to go wrong, you're going to be alerted for that. You can set up thresholds when you're going to be alerted. Let's say you have a particular budget assigned to your project, and you don't want to exceed it, right? You can set up the Azure Monitor for that. So Azure Monitor is going to be in real time, it's going to be evaluating the products that are being used on resources that are being used by your virtual machine or by your application, and it's going to alert you on basis of your budget. Let's say your budget is about to you are about to hit your budget. You're going to get a notification that hey, XYZ person, your project XYZ is going to hit its budget. You might want to take a look at it. So I'm just giving you an example. That is what an Azure Monitor can do in terms of your virtual machine, in terms of your application and container. Then there is visualization. So visualization is going to be mostly used by data analysts, and which I think is, data is something that allows you to take a better decision in literally every organization right now. So you can create a real-time dashboard. We use Power BI. Power BI is a data analysis tool wherein you can program it to aggregate different data, or to utilize or visualize different data that is available. Similarly, you can analyze through the log. You can create alerts, as we talked about. That is the response to any kind of metric that you get from above. Or you can auto scale, right? Obviously, uh, that is something load balancer can also do. You're about to reach the threshold, replicate the virtual machine, replicate the server, and make more resources available. And then there is integration. Like for example, like cloud functions, that's how they work, right? They are monitoring different events, and based on an event, they fire a new instance of cloud services, do the job, go back. So that is how an Azure Monitor works, and that is what an Azure Monitor can do for you. Yeah. So we have set up our function app. Maybe I can show you how SQL database works, right? I can show you how to create an SQL database, how to utilize it. Okay, so let's say I just clicked on create a SQL database. I am now here configuring the basics. We have, uh, let's not worry about subscription now. We have a database. So you can create a database. You can name your database. Let's say now I can just say test DB. I can select a server for it, which apparently I have no servers running, right? So I can create a new server. Let's name it DB host, because that's how programmatically you are going to access it later on. Alrighty. Location, as we talked about, DB host test Azure. All right. Now, as you already talked about, you can opt for a zonal database, or you can choose any location where your server is going to access it faster, right? For example, I just select something South India because, okay, right now I'm on free subscription, so I'm going to use the East US, which is basically free for us. You can set up the kind of authentication, and then you can use the Azure AD authentication, as we talked about, the Azure Active Directory, where you assign roles dynamically. You give them certain role, or you cancel the role anytime. And you can also programmatically utilize this Azure AD by using Cloud Auth proxies. Now, that is server admin login. You can, let's say, I can give some particular username and some password. Let me just go with the suggested password. Right. Okay. Alrighty. So that's it. And you're in backup storage, not database. Review plus create. All right. So here, you're going to review the server that you just configured. This will create a virtual machine and run an SQL server on top of that, right? We have a server name and we have our server up and running. Now, if we go through the details, this is basically what everything that we have opted for. And yep, I think that's mostly it, right? So that's how you create an SQL database. Right now, I'm not actually creating a database because of my subscription issues. Right now, I'm on a free plan, and yeah, on that Microsoft Azure service, you can basically go to any service, create a new service, get your service up and running, and then scale it on demand, right? For it, and now there are different containerization pools that you can run as well. For example, you have the support for running containers, Docker containers on cloud, and you have the support for running Docker containers within Kubernetes to manage and auto scale the services. So there is a plethora of different around 100 plus services that you can actually use on Azure and on Azure and do everything you want to. For example, just within compute services, I have virtual machines classic. There are container instances wherein you just define your Docker file, or you just define your container, let's say, which can be hosted in any registry like Docker Hub or your uh, Azure's own private registries, and you can pull the containers from there and just start them running. Then there are Kubernetes services, cloud services, basically a lot of things that you can do for computing. Then there are not a lot of services that address networking problems. You can utilize most of them. You can set up your own um, DDoS protection servers even. Then you have the location, then you have the flexibility to use or rent out or lease storage based on your needs. And like we talked about, this is a Azure managed cloud service, so here you don't have to worry about storage limits. Like virtually it's infinite for you. Anything that your application wants, you have the access to it. That's basically what storage promises. Then you have a lot of web services for you, available mobile containers and databases, and the list goes on. So I hope this session gave you an insight towards what Azure can do and how it can power your future projects. I hope that you use it anytime soon. And I hope that this session basically gave you a curiosity or a basic overview of what Azure can do for you and how you can leverage its computing power, its networking capabilities, and storage, and everything that it provides to run your projects, right? In case of any doubts, please let me know. Is it free service or there is limit for subscription? Initially, as a student, it's going to be free for you, right? Most of the times it's going to be free for you. While you are a student, you can utilize Azure services by signing up with your college provided email IDs, and you can use it. And you can renew it every year, if I'm not wrong. And yep, Azure Monitor, is that a question? Like, do you have doubt about Azure Monitor, or what, like, is there some specific question that you have about Azure Monitor? Yeah. Okay. I hope your question is answered. And if there are any questions, please let me know in the comments, or we can wrap up with the session about introduction to Azure fundamentals. Yeah, you right now do not have any limit. Like, there is certain limits, like that you get about access to 25 or 30 free services when you sign up with a student email ID. But later on, you can renew it. Uh, but yeah, there are certain limitations, and most of your project that you will be building are going to be personal projects, right? These are not enterprise projects that need to be up and running with an infinite amount of auto scaling enabled. Those limits which come up with the free account, you're most of the time not going, 99.9% of the time you're not going to break those limits. So it's virtually free for you. Alrighty. So I hope the session was insightful for all of you. It gave you a curiosity of how and when to explore Azure, and when Azure can be the right product to power your personal projects. And I hope it gave you some insight of how to get started with Azure. So on that note, I'm concluding this session, and let's catch up later and let's dive it more into programming, deeper into Azure fundamentals when it's the right time. Alrighty. Take care, and bye bye.